December 14, 1972, the last time a human being stood on the surface of the moon. 52 years have passed since that day. In the decades that followed, the space shuttle flew 135 missions. The International Space Station circled Earth more than 130,000 times. But not a single human being traveled beyond low Earth orbit. Not one. Right now, at Kennedy Space Center in Florida, a 98-meter-tall rocket stands on Launch Pad 39B. SLS, the Space Launch System, 5 meters taller than the Statue of Liberty. When fully fueled, it weighs 2.6 million kilograms. At liftoff, it produces 8.8 million pounds of thrust. It is the most powerful rocket built since the Saturn V. Sitting on top of that rocket is the Orion Capsule, 5 meters in diameter, 4 seats. A spacecraft designed to survive 10 days between Earth and the Moon. This is Artemis II, the mission that breaks 52 years of silence and sends humans back toward the Moon. Development alone cost $11.8 billion. A single launch costs roughly $2 billion more. It is the most expensive rocket in history. But if this flight succeeds, humanity stands at the threshold of the Moon once again. A capsule returning from the Moon hits Earth's atmosphere at 11 kilometers per second. Friction superheats the surface to roughly 2,760 degrees Celsius. That is nearly twice the melting point of iron. The only thing standing between the crew and that inferno is a single shield bolted to the bottom of Orion, the heat shield, 5 meters across. The largest heat shield ever built for a crewed spacecraft. The material is Avcoat and ablative, compound NASA has used since the Apollo era. 186 tiles are arranged in a honeycomb mosaic. They work by melting, absorbing heat, and shearing away layer by layer. Here is the problem. During the uncrewed Artemis I flight in 2022, parts of this shield eroded in unexpected ways. Some tiles detached outside the predicted zone. NASA spent more than 2 years investigating. The conclusion: the shield is safe if the re-entry flight path is adjusted. For Artemis II, engineers will alter the atmospheric entry angle to redistribute thermal loads across the shield's surface. But not everyone is convinced. Some independent experts still have concerns. The heat shield debate is ongoing right now, and whether this shield can truly protect 4 human lives is a question only the actual flight can answer. The flight path of Artemis II is the same type. Apollo 13 used to get home alive, a free return trajectory, a route designed so that even if the engine fails, the Moon's gravity alone slings the capsule back toward Earth. The mission breaks into 6 phases. Phase 1, SLS launches Orion into low Earth orbit. Liftoff to orbit insertion takes about 8 minutes. Phase 2. Orion climbs to a high Earth orbit, an ellipse with a period of roughly 24 hours. Its high point above the altitude of communications satellites. The crew tests life support, navigation, and comms. Phase 3, trans-lunar injection. The European-built service module engine ignites, and Orion escapes Earth's gravity well, heading for the Moon. Phase 4, lunar flyby. The capsule passes within approximately 8,000 kilometers of the lunar surface. Through the window, the crew sees the far side of the Moon with their own eyes. The last humans to see that view did so in 1972. Phase 5, return. Lunar gravity bends Orion's path back toward Earth. No additional engine burn is required. That is the core advantage of a free return trajectory. Phase 6, atmospheric re-entry and Pacific splashdown. 3 parachutes deploy. IUS. Navy amphibious transport dock recovers the capsule and crew. Launch to splashdown 10 days. Those 10 days must succeed before humanity can set foot on the Moon again. February 3rd, 2026. 5 minutes and 15 seconds before the count would have reached 0, the clock stopped. This was the wet dress rehearsal, a full-scale test where the rocket is fueled, and the countdown proceeds exactly as it would on launch day. During that test, liquid hydrogen began leaking from the umbilical connection at the base of the rocket. Hydrogen is the lightest element in the universe. Its molecules are so small they seep through microscopic gaps in metal. The temperature of liquid hydrogen is minus 253 degrees Celsius. If leaked hydrogen meets oxygen, it explodes. This is not a new problem. Hydrogen leaks plagued the space shuttle program for decades. Artemis I needed 3 fueling attempts before it finally launched in 2022. SLS inherits the shuttle's main engines and solid rocket boosters, and with them a structural vulnerability to hydrogen leaks. NASA announced the fix could be done on the pad. No rollback to the vehicle assembly building would be needed. Then, on February 12th, engineers quietly ran a second fueling test. The original launch date of February 8th has slipped to March 6. Backup dates are March 7, 8, 9, and 11, then April 1st through 6, and finally April 30. For a species that waited 52 years, one more month may seem insignificant, but if the leak is not fully resolved, the launch window keeps sliding further into the future. The moon is roughly 384,000 kilometers away. A radio signal takes about 2.5 seconds to make the round trip. Conventional deep space communication relies on radio waves. Data rates top out at a few megabits per second. Sending a single photograph can take minutes. Artemis II carries a device called O2O, the Orion Artemis II Optical Communications System. In plain terms, it is a laser communicator, a 10-centimeter telescope mounted on Orion's exterior. Fires an infrared laser beam toward Earth. Ground stations in California and New Mexico receive the signal. The downlink speed is 260 megabits per second. That is tens of times faster than radio. At that rate, the crew can stream live HD video from lunar orbit back to Earth. Compare that to the grainy black and white footage. Apollo 11 sent home in 1969, it is a different era entirely. If O2O is validated on this mission, it becomes the first building block of a deep space laser network, stretching all the way to Mars. Mars is hundreds of times farther than the moon. Radio alone cannot carry the volume of data future missions will need. Only laser links can close that gap. The first laser signal Artemis II sends back to Earth is not just footage of the moon. It is the opening test of the communications highway to Mars. The crew of Artemis II numbers 4, but the makeup of this crew is unlike any that came before. A commander, a pilot, and 2 mission specialists. One of them becomes the first person of color to fly toward the moon. Another becomes the first woman to travel this far from Earth. A third becomes the first non-American to orbit the moon. A member of the Canadian Space Agency, assigned under a 2020 treaty between the United States and Canada. But here is the twist. None of them will land. Artemis II is a test flight. Its purpose is to prove that SLS and Orion can carry humans to the moon and bring them home alive. The actual landing belongs to the next mission, Artemis III. Still, what these 4 must accomplish is far from trivial. They need to verify that life support works in deep space, that radiation shielding holds, that manual piloting and proximity operations are feasible, and that the heat shield can actually protect 4 lives during re-entry. All of this must be demonstrated within 10 days. Inside Orion, there is also a device called Avatar, organ-on-a-chip hardware that simulates human tissue. It will be exposed to space radiation and microgravity to measure the long-term effects of deep space travel on the body. This is not a lunar sightseeing trip. This is the final rehearsal before humanity walks on the moon again. The moment Artemis II splashes down in the Pacific, the next question begins. Can humans actually land on the moon? Artemis III, target date 2028. The first mission to put humans on the lunar South Pole. The South Pole harbors permanently shadowed regions, and growing evidence suggests those shadows contain ice. That ice can be converted into drinking water, breathable oxygen, and rocket propellant. If resources can be harvested on the moon, it means a staging base for Mars becomes possible. On Artemis III, 2 of the 4 crew members will descend to the surface aboard a Starship HLS lander and spend roughly a week exploring the South Pole. The other 2 will wait in lunar orbit inside Orion. But every part of that plan hinges on the success of Artemis II. Orion must carry 4 people to the moon and back safely before a landing mission gets the green light. 5 international CubeSats will also ride along on Artemis II, small satellites from Germany, Argentina, South Korea, and Saudi Arabia, nations that signed the Artemis Accords, will conduct radiation and communications experiments in high orbit. 52 years ago, the moon was a stage for 2 superpowers. Now it is a shared destination for many nations. The 10 days of Artemis II are not just a lap around the moon. They are the first stride towards staying on the moon and eventually reaching far beyond it.